Hello friends, in this video we're going to be working with parabolas, and what we're going to be trying to do is we're going to be trying to find the vertex, focus, and directrix of a given parabola. So in this video I have a beautiful equation here that we're going to be working with. We have y equals x squared minus 6x plus 4. And since we have this given equation, the first thing that we have to do is we're going to have to try to get it into some standard form. So in order to do that, right, we have to compare what this looks like with our two standard forms. So we have, this is one of them, right? This is the form for symmetry about the y-axis. And we know that because this value right here, this tells us what our symmetry, our axis of symmetry is. So this tells us the axis of symmetry. And here we know it's the y-axis. So when we look at this equation that we've given, what we see is we have an x squared, right? The only way we can get an x squared out of our two standard forms, whether it be about the axis of symmetry with y or they have the axis of symmetry x, we want the axis of symmetry to be y because what we see is that here we have x minus h squared. So our x is going to be squared again. So we have an x squared, over here we have an x squared, so we know that our axis of symmetry for this equation is going to be our y-axis, right? So what we're going to be trying to do is we're going to try to get this equation to be in this form, to look like this. So to get us started, we have to kind of find a way to rewrite our items with our x, right? So we have x squared minus 6x plus 4. We have to rewrite that to get some x minus h parentheses squared, right? We have to write it in this form. Unfortunately, there's no way to do that. So, in order to eventually get to this form, what I suggest doing is we're going to subtract our 4 over to the other side. So what we're going to get is we're going to get y minus 4 equals x squared minus 6x. And now what we have to do to get this standard form is we're going to have to complete our square. So in order to do that, we have to use our equation for completing the square. And what that is we're going to take our b over 2 squared. And that's what we're going to plug in right here, right? So our b is negative 6 divided by 2 squared. So 6 divided by 2 is negative 3. So we have negative 3 squared. Negative 3 squared is just 9. So what we're going to be doing is we're going to be adding 9 to both of our sides. So I'm going to erase this work right here. So now that we know that we're adding 9, and I'm going to do that. So I'm going to add 9 here. And whatever you do to one side, you have to do the other. So I'm going to add 9 to this side as well. So our grand total now, we're going to have a beautiful y, 9 plus negative 4 is going to be 5, right? So 9 plus 5 equals, we're going to have x squared minus 6x plus 9. So now that we have it in this nice form, we can break it down into our x minus h parentheses squared, because we see that this is the same thing as x minus 3 times x minus 3, right? Since we completed the square, we can now rewrite this all as, we'll have y plus 5 equals x minus 3 squared. So what we see is that we've kind of gotten it into this form, right? We see that we have, if we were to rewrite this, flip it around, right? We are going to have x minus 3 squared equals y plus 5. That is our standard form. So now that we've gotten in the standard form, I'm going to erase our work here and rewrite this so we can do our work to find what our directrix, focus, and vertex are for this equation. So I'm going to rewrite him up here. So we're working with, have x minus 3 squared, right, equals y plus 5. So we know what our axis of symmetry is. We know it's the y-axis, right? So that's good. So what do we need to figure out now? We need to figure out what our vertex, focus, and directrix are. So from our standard form, we can determine our vertex from this right here, from our H and from our K. These tell us our vertex, because our vertex is going to be H, comma K. So with this guy over here, we know our vertex is going to be our H is 3, and our K, because we have a positive here, right, it's going to be negative 5. So that is our vertex. Now, what we need to figure out next is we need to figure out where our focus and directrix are, right? So in order to do that, we need to look at this value right here. Let me grab 1 second, a different color. We're looking at this guy right here. What this guy does is P tells us the distance between our focus and our vertex and our directrix and our vertex. And it tells us both of them because they're both the same value. Our focus and directrix are always a equal distance apart from our vertex. So, and it also tells us one other thing. It tells us if our, I'm going to write this up here, if P is greater than 0, what's going to happen is our parabola is going to open up. And if P is less than 0, it tells us that our parabola is going to open down, right? So all that can be figured out with this part right here. So what we have to do though, is we have to identify what that value is in our function, right? Right here. It's whatever that's out in front of this, right? Which is really just a 1, right? Because we have 1 times anything is itself. All we have here is y plus 5. So you multiply it by 1, we still get the same answer. So our 4p in our standard form is equal to 1. So we're going to make that, set those equal to each other. So we're going to have 4p equal to 1. And now we're going to solve for p. So by solving for p, we're going to divide by 4, both sides. So we get a grand total of p equals 1/4. So we know that the distance between our focus and our directrix, or excuse me, our focus and our vertex and our directrix and our vertex is going to be 1/4. And we know that since our p is greater than 0, our parabola is going to be opening up. So, you know, p is greater than 0, so we're going to open up. So now that we know all of these things about our p value, right, we have to find what our focus and directrix are. So I'm going to erase this so I can draw a picture of what we're working with to kind of help us visualize how we figure these two values out. So we know our focus is a point, right, and our directrix is a line. So that's going to come into play as well in a second. So let's graph this and see what we're working with, right? So if this is our beautiful graph, we're at we know where our vertex is, right? So we're at 3, negative 5. So 1, 2, 3. 1, 2, 3, 4, 5. So this is the point where our vertex is. And we know that we said that he's going to open up. So that's good news. So just drawing like a rough sketch of what this is going to look like. He's going to be something kind of sort of like this, right? Our parabola. So what we need to find now is our focus and directrix, right? So our focus is going to be a point inside of our parabola, right? It's some point in here. And our directrix is a line that's underneath our parabola. And we know that the distance from our point, our vertex, to our focus is going to be 1/4. So that means this guy, the point, our focus, is going to be 1/4 up from there, which that is not mapped very well on with respect to my scale for my graph here at all, but I wanted to make sure you can kind of see what we're doing. So our focus is going to move up 1/4. So if it moves up 1/4, what we're going to be doing is for our focus, we're going to be taking, it's the x value is going to stay the same, right? The x value doesn't change, so we're going to be taking the same x value as our vertex, and then we're going to take our -5, and we're moving up 1/4, so we're going to add 1/4 to it. Right? And so since we have a -5 plus 1/4, what we're going to get is a 3, and when we add the 1/4, it's the same thing as 0.25, right? So we're going to get -4.75, or 4 3/4. So if you'd rather think about it that way, I have a 4 3/4. Right? I'm going to leave it in decimal form for now, just because I think it's a little easier to understand. So you have 4.75. Now, like I said, our directrix, when we look at that, right, our directrix is a line that's the opposite, right? Our focus is inside our parabola. The directrix is a line that runs underneath it here in this problem, right? If it's flipped, the directrix, like if we have a parabola that looks like this, our directrix is going to run on top because our focus is always on the inside, right? So just for an explanation example. So our directrix is this line down here, and we're going to be moving down once again, like I said, 1/4. So, and we see that our directrix is a horizontal line. So since it's a horizontal line, we know that it's going to be some y equals, right? So directrix is going to be y equals something, right? Because our y value is going to stay the same. Whether you're at x equals 1, you're still going to have the same y value. X equals what? 2, you're still going to have the same y value. So when y equals, and we're going to be taking the point we're at with our vertex, right? So we're at -5, and we're going to be moving down 1/4. So we're going to be subtracting 1/4 from here. So what we're going to get is we're going to get -5.25. Y equals -5.25. That is our directrix, that line. So we have a focus, we have our directrix, and we've found our vertex. We know our axis of symmetry is the y-axis, and we know that because our p-value is greater than 0, the whole thing points up. So that will help us graph the basic function for our parabola.